My name is Ben Talbot. I'm a research fellow and I work in the Visual Scene Understanding project within QCR. In our group, what we're looking at is this bigger problem of when a robot goes into the world, we want it to be able to do these impressive things like pass me the coffee cup. But before it can do that, we have to drill down, and the robot has to understand the world around it. It has to understand where things are, what they are, and also the semantics about it. How does it know what the coffee cup is? How does it know where it is? How does it know it can pick up a coffee cup? So in the visual learning and scene understanding stream, we're trying to look at how can we get robots to understand the world so they can do useful things in the world. In my work, what we've looked at is how do you even get a concept or notion of a robot understanding the world? You can test it in some abstract simulator and it might do well there, but it could be contrived. You can spend months on your real robot system setting things up and it may work there in your one contrived experiment, but does that really prove, or have you got a comprehensive understanding of how your robot understands the world? So in my work, what we've created is this system called BenchBot, and it's looked at if you take some novel robotics research for visual learning and scene understanding, you take that body of research and using BenchBot, you can apply it in a photorealistic 3D simulator across a wide array of scenes and environments and trajectories, and comprehensively examine the performance of your scene understanding algorithm. And then the big kicker is you can take exactly the same code body and chuck it straight on a complex real-world robot system and see if what you think you've achieved in terms of scene understanding in simulation actually transfers to the real world. Testing our robots rather than saying we think it's all good and then throwing it in the real world and having bad consequences. That's definitely not what we want. So what we've done in BenchBot, we've done a lot of work on what we've called an Addons system, and it caters to two different styles of users of BenchBot. We've got the users who might be interested in certain tasks. They want to examine research on, can a robot answer semantic questions about the world? Can it create semantic maps of the world? Can it understand when things have changed in the world? And we can use add-ons to create these different types of scenarios where you want to examine your algorithm's performance. And then we've got our users who can, using really basic programming tools, not worrying about the complexities of a robot system and all the interconnected nature that often causes issues, just focus on using Python programming with their algorithm. Does it work for that task that someone else has defined? So we've put a lot of effort into making the system modular, so you define or work in the bits you want to be working in, and you use the bits that other people have created to combine it into a system.